Welcome back. In this session, we are going to discuss worksheet questions of mechanical properties of solids. Let's go. One end of a steel rod of radius 10 mm, radius r is equal to 10 mm. Unit conversions important, 10 to the power of minus 3 meter. And length L is equal to 50 centimeter, can take it as 10 power minus 2 meter, clamped on a horizontal table. The other end of the rod is pulled with a force of magnitude F is equal to 10 into pi kilonewtons, I think so, 10 to the power of 3 newtons, kilonewtons. The force is uniform across the flat surface of the rod and is represented and is perpendicular to it. The change in the length of the rod due to this applied force is elongation is how much? And Young's modulus Y is equal to 2 into 10 to the power of 11 Newton per meter square. Elongation, we have a standard basic formula Y is equal to FL by AE. Practice this formula alone by writing 10 times. You can answer almost all the questions from this chapter. So elongation E equal to FL by AY. F 10 into pi into 10 to the power of 3. L is 50 into 10 power minus 2 by AY, A value pi r square, A value pi r square. Here only I will write A equal to pi r square. So pi r square 10 to the power of minus 2 square into Y, Y value 2 into 10 to the power of 11. After simplification, I am going to get the option as 0.25 mm. Cheating, no cheating. This is managing the time to discuss more number of problems. Okay, you can simplify that. That's not a big task. An object of mass 15 kg is attached to the end of a metal wire. An object of mass m is equal to 15 kg is attached to the end of a metal wire. Unstretched length is L is equal to 1 meter. The object is then whirled in a vertical circle with angular velocity omega is equal to 4 radian per second. At the bottom of the circle, if the cross-sectional area A is equal to 0.05 centimeter square into 10 to the power of minus 4, so that it will come in meter square, and Young's modulus Y is equal to 2 into 10 to the power of 11 Newton per meter square. Elongation at the lowest point E is equal to FL by AY. What is the force F? When a suspended string is whirled, suppose, see, vertical circle, then here it is going to have a tension, the tension or the stretching force, that is mg plus mr omega square, both must be balanced by tension. So that force F is equal to, here the formula is FL by AY, and F is nothing but mg plus mr omega square. So I can write this as mg plus ml omega square, radius is length of the string only, right, into L by A means pi r square, area only given, yes, Y. So E is equal, substitution I will write, simplification you need to do. M is equal to 15 into G value 10 plus L value 1 into omega square is 16 into L is 1 by cross-sectional area is 5 into 10 to the power of minus 6, just I manipulated this, into Y value 2 into 10 to the power of 11. Steel wire Young's modulus is 2 into 10 power 11. Yeah, if it is this much of simple, then everybody can do. 15 into 26 by 5 2s are 10 into 10 to the power of 11 minus 6. Anyway, its simplification will give you in mm. So how much that is? 0.39, 0.39 mm. Next, matching the following: shear modulus, shearing stress, elastic fatigue, modulus of elasticity, and these are the options. So we have to match this. So matching is like this: shear modulus A, shear modulus A, resistance to change in length, change in volume, proportionality constant, modulus of elasticity is proportionality constant, so d2, and then yeah, so it's B option. Okay. Next one, elastic fatigue, temporary loss, elastic fatigue, C4, yeah, it's almost all B is matching. Okay. And shearing stress, resistance to change against deformation force is stress. Stress is against to deformation, so B5. So B5, it's matching. And tangential stress, and then shearing modulus is okay, so resist opposite to it, fine. So option B, memorable things, right? Two springs of force constant K1, K2 are loaded with weights W1, W2 respectively. Assume that the length of each string is increased by same amount. Okay, if K1 is equal to 2K2, then the ratio of their weights is equal to, okay, elongations are same, F is equal to Kx, we have the formula in magnitude. So it can be represented as W1 is equal to K1 into X, and W2 is equal to K2 into X. He said K1 is equal to K2. Okay, fine. He is asking W2 W1. X's are equal. W2 by W1 is equal to K2X by K1X. X's are equal. And K2 by K1 given as K2 by K1 is equal to 1 by 2. K2 by K1 is equal to 1 by 2. So that is 0.5. Correct only. Next. Consider a rod of length L is equal to 1 meter with a cross-sectional area A is equal to 0.5 centimeter square, 10 power minus 4 meter square. Remember, whenever CGS units, if you notice, immediately change them. The rod supports a weight or mass, I can write mass M is equal to 500 kg platform that hangs attached to the rod's lower end. And what is the elongation of the rod under the stress, ignoring the weight of the rod? Okay, what is the elongation? E is equal to how much? Consider the Young's modulus. Y is equal to, he has given Y is equal to 10 to the power of 11 Newton per meter square, that only Pascals, and G value equal to 10, he is asking meter per second square. Okay. E is equal to FL by AE only, no choti, FL by AE. Here AY it will be. So E is equal to, F is equal to mg 500 into G, L is 1 by area 0.5 into 10 to the power of minus 4 into Y value 10 to the power of 11. So this is in a clear way Y, AY. That's what I told. Learn this formula very carefully so that many problems you can solve. Many. This is 5 and 5 will go. Why should I? No repetition of step. 1, 2, 3 zeros are there on the top. 5 gets cancelled already. So 10 power minus 1, 10 power minus 5. 10 power minus 5 plus 11. So it will be 10 to the power of, all are 10 to the power of, that means option D only there is a possibility. Yes. So 3 plus 5 minus 11 meters. So obviously will come in mm. Next, a slab of side A is equal to 50 centimeter into 10 power minus 2 meter, and thickness T is equal to 10 centimeter, 10 power minus 2 meter. thickness is subjected to a shearing force of 10 to the power of 5 Newton. Shearing force means tangential force, which is equal to 5 Newton. Oh, 10 to the power of 5 Newton. Wow. And on the narrow edge, if the lower edge is riveted on the floor and upper edge is displaced by x or e, x is equal to or e is equal to 0.2 mm, 10 to the power of minus 3 meter, then shear modulus is equal to eta is equal to here actually FL by theta we have to think. You see, this is the body fixed at the lower surface and shifted like this. Okay, then this is x and this is L. So strain is equal to x by L. So shear modulus eta equal to force by area into x by L. So FL by AX will come. FL by AX. A equal to 10 to the power of 5 into L is equal to 50 into 10 to the power of minus 2 by area is 50 into 10 power minus 2 into 10 to the power of minus 1. That means this product will give you area, and into 0.2 into 10 to the power of minus 3. So it is going to become 50 into 10 power minus 2, 15 10 power minus 2 will go. So 10 to the power of 5 and this minus 1, minus 1, minus 3, total minus 5. So that means here plus 5 by 2 will be there. That means 10 by 2 into 10 to the power of 9 I can write. This is nothing but 5 into 10 power 9 pascals. That means it is 5 gigapascal. Yes. Next. A horizontal aluminum rod of diameter 4 centimeter, whatever be radius equal to 2 centimeter, which is into 10 power minus 2 meters, and is projected 6 centimeter from a wall. A horizontal aluminum rod 6 centimeter wall, projected 6 centimeter from a wall. That means wall is like this, it is projected like this. Okay. An object of mass m is equal to 400 pi kg is suspended from the end of the rod. So here it is suspended from the end of the rod like this. Okay, and the shearing modulus eta is equal to 3 into 10 to the power of 10 Newton per meter square. The vertical deflection of the end of the rod is equal to, so that means lateral shift he is asking, x is equal to question mark. X is equal to, see, we have eta is equal to FL by AX. So x is equal to FL by A eta. So x is equal to FL by A eta. F is nothing but mg L by A eta. Mg L by A eta. Here L is also whatever that radius will come. So it's a, which type of rod it is? Rod of diameter only. Okay, fine. So let us substitute. That is equal to m 400 pi g 6 centimeter projection he told. Okay, 6 into 10 to the power of minus 2 by a pi r square 2 into 10 to the power of minus 2 square into eta. Eta is 3 into 10 to the power of 10. So the option is, after simplification, we will get 0.02 mm. Actually 0.000002 meters will come. So after converting into mm, this is the better one. Next. Young's modulus of a material y is equal to 2 into 10 to the power of 11, and elastic limit is, that means breaking stress I can call, or elastic limit, 1 into 10 to the power of 8 Newton per meter square. This is also Newton per meter square. For a wire of length L is equal to 1 meter, for this material the maximum elongation achieved E is equal to how much? Maximum elongation achieved. This is F by A. E, this is actually F by A. F by A. So E is equal to FL by AE. This is already given separately. So this is 1 into 10 to the power of 8. L value 1 meter by FL by AE is equal to Y actually. So F by A already wrote. L value already wrote. E value E, that only I have to find. Y is equal to 2 into 10 to the power of 11. So E is equal to 2 into 10 to the power of 11 by 1 into 10 to the power of 8. So it will be 2 into 10 to the power of 11 minus 8 is 3. 2 into 10 power 3. Any unit conversions are there? Newton per meter square, Newton per meter square, length 1 meter, maximum elongation produced is equal to E on 2, and this will be minus. This is here I did reverse. See, you shouldn't do in a hurry, you have to do in cool. So that is 10 to the power of 8 by 2 into 10 to the power of 11. That is 10 to the power of minus 3 into 1 by 2. So that means 0.5 mm. So next, length L is equal to L naught plus elongation. Length L is equal to L naught. L naught is L naught. Elongation is force by K. F by K is elongation, right? Force by K. So 4 by K. K is a force constant. And B is equal to L naught plus 5 by K. Solving these two, solving means we have to solve it for L naught and for K. Both we have to find out. So for L naught and K we need to find out. For that we will do like this. Suppose this is A minus L naught is equal to 4 by K, and this is B minus L naught is equal to 5 by K. Dividing one with other, we are going to have, A minus L naught by B minus L naught is equal to 4 by 5, and on cross multiplication we are going to get 5A minus 5L naught is equal to 4B minus 4L naught. So L naught is equal to 5A minus 4B, representation 1. So we should be patient enough to do such big problems. Next, K value we have to find out. So K. For that K value, we can substitute this L naught in the one of the equation. See, you got A minus L naught is equal to 4 by 5A minus, K value we have to find, right? This is K only. Here K. This is K. This is one of the equation. A minus 5A minus 4B is equal to 4 by K. So this is minus 4A plus 4B equal to 4 by K. 4 gets cancelled. So K is equal to 1 by B minus A. Now whatever the requirement, we need to go for the required. Required length L3 is equal to L naught plus F by K. F by K, that is tension by K. Tension T3 by K. So L3 is equal to L naught is 5A minus 4B in plus T3. T3 is 9 newtons by 1 by B minus A. So it is going to become L3 is equal to 5A minus 4B plus 9B minus 9A. So it is going to become 5A 9A. Okay, 4B 5B minus 4A. Yeah, 5B minus 4A. Option B. Such a small question it is. Next. The work done in stretching a spring of natural length 25 centimeters and spring constant 50 Newton per meter. Natural length L naught is equal to 25 centimeter. Spring constant K is equal to 50 Newton per meter from x1 is equal to 50 centimeter to x2 is equal to 60 centimeter. Work done, W is equal to half kx square k into x2 square minus x1 square. That is equal to half k value 50 into x2. X2 is not this one actually. Elongation one we have to take. Elongation. Elongation means difference of this. 60 minus 25 square minus x1. x1 50 minus 25 square. So into 10 power minus 4 must be because centimeters unit conversion. So that is equal to 25 into 35 square minus 25 square into 10 to the power of minus 4. This is 1.5 joule. Yeah. Copper wire of length L is equal to 2.4 meter and an aluminum wire of length L is equal to copper wire, aluminum wire 0.7 meters, both having diameter 2 mm only, diameter 2 mm, both connected end to end. Okay. When stretched by a load, the obtained elongation is found to be combined wire elongation 0.6 mm. The applied load is dash. Young's modulus of copper wire is Y1 is equal to Young's modulus of copper wire is 1.2 into 10 to the power of 11 and Young's modulus of aluminum, first copper wire only, next aluminum only. That should be checked. 0.7 into 10 to the power of 11. Both are in Newton per meter square. Okay, so whenever both are connected in series, that means end to end, one wire is like this and another wire is like this, both are connected end to end, then both are going to suffer equal tensions provided their masses are negligible. So here and here the tensions will be same, so forces will be same, whatever that suspended load, provided their masses are negligible. That's important. So in that aspect, elongation produced is equal to E1 plus E2. E is equal to E1 FL by A1, FL by A Y1 plus FL by AY2. Here F is taken common, that only we have to find, right? L1 by A1 Y1 plus L2 by A2 Y2. So that is equal to E. Let us substitute. Substitution. E is 0.6 into 10 to the power of minus 3 is equal to F I have to find into L1 2.4 by A1 A pi r square, right? Pi r square. This means r is equal to 1 mm 10 to the power of minus 3. So pi can be taken common. So pi r square is 10 to the power of minus 6. Y value, in Y value 10 power 11 also I want to take common, 10 to the power of 11. I can write inside only 1.2 here plus, and this is length 0.7 by length 0.7 into, this is also area same, okay, 10 to the power of minus 6 as I took. So yeah, 0.6 into 10 to the power of minus 3 by F by pi into 10 to the power of 11 into 10 to the power of minus 6 also come out. This is 2.4 by 1.2. Yeah, and this is just plus 1. So after this, answer will be in pi only. Yes, pi. So 24 by 1.2, 2 times 3, that will be 3. So 3 will go 0.2. 0.2 into pi into 10 to the power of minus 3 plus 11 minus 6 is equal to F. Answer will be with 2. So option is 20 pi newtons, that is equal to F. Next. Same tension is applied to the following 4 wires of made up of same material. Same material indicates Y value same. The elongation in longest is longest in which case elongation is more. Elongation E equal to FL by same tension. F same, FL by AY, this is also same. So elongation is more for more L by Y value. More L by Y value we need to check. E is equal to more L by Y value. L by Y for the first one, for the first option, 50 centimeters by this is 0.5 square only I would like to take. All are of same units, that's why. 0.5 means 1 by 2. 1 by 2 square means 1 by 4. That means into 4 I want to take. That is 200, some dummy units. And B is equal to 200 centimeters by pi r square. So that is 4. 4 means 50 will come for this. And C will be 300 by 9 will come for this. And D will be 100 by 1 will come for this. He is asking elongation is longest, more value should come. More value is obviously for A. Yeah. So like this you can compare. L by A you have to compare. Next. A body of mass M is equal to 10 kg is attached to a wire of L is equal to 0.3 meter. The braking stress F by A is equal to braking stress is equal to 4.8 into 10 to the power of 7. The area of cross section of the wire A is equal to 10 power minus 6. Maximum angular velocity with which it should be rotated. A body mass M attached to a wire, braking stress this one. So that one thing he forgot to give, is it rotated in vertical circle or horizontal circle? That you need to confirm with the question properly. As he didn't mention, I am taking that only horizontal circle. If it is horizontal circle, the tension must be balanced by mr omega square. So that should be supportable to braking stress. So I can call braking stress force by area. Force by area, braking stress is equal to tension by area. Tension is equal to mr omega square by area A, cross section area A. So braking stress 4.8 into 10 to the power of 7, that is equal to M, mass is 10 kg, into R, radius is 0.3 meters, into omega square I need to find, by area, cross section area 10 power minus 6. Hope everything are in proper units. Then omega is equal to root over, values are 4.8 into 10 to the power of 7 into 10 to the power of minus 6 by 10 into 0.3. Yeah, it's a simplification. This will be 3. 3 will go 1.6. Root over I'll get 1.6 into 10 to the power of 1. 16. Answer will be 4. 4 radians per second. Yeah. Next, if a pressure of 8 into 10 power 8, pressure of 8 into 10 to the power of 8 Newton per meter square is applied to a lead block. Okay, so that the volume is reduced by, change in volume is reduced by 20%. That means delta V by V is 20 by 100. The bulk modulus V is equal to, increased pressure by change in volume we have to take. Increased pressure 8 into 10 to the power of 8 and this is 20 by 100. So that is 0 gets cancelled. This is 2 by 10, 1 by 5, that 5 will come up. 5 8s are 40 into 10 to the power of 8. So that means 4 into 10 to the power of 9 Newton per meter square. So option is C. Next, that is 10 power 9 only. A long steel wire L is equal to 3 meter. Wire is stretched to increase its length by 0.3 centimeters. Increase its length by 0.3 centimeters into 10 power minus 2. Poisson's ratio for steel is 0.26. Poisson's ratio for steel is sigma is equal to 0.26. Okay, the lateral strain, that means delta R by R, lateral strain. Longitudinal strain is E by S. This is equal to question mark. You know, delta L by L is how much? Delta L by L 0.3 into 10 power minus 2 by 3. So that is 0.1. 0.1 means 10 power minus 3. This is longitudinal strain. Sigma equal to lateral strain by longitudinal strain. So lateral strain is equal to sigma into longitudinal strain. Sigma is 0.26. Longitudinal strain 10 power minus 3. So option is as per that 0.26 into 10 power minus 3. Yeah, correct. There are no units for any kind of strain or Poisson's ratio. The following 4 wires are made up of same material. Young's modulus will be same for same material. Same tension T is same applied to each and having largest extension. Largest extension is given by E equal to FL by AY. This F is same, Y is same. So it's proportional to L by A. That only you have to check. First option 0.5 by 5 mm square. That means it's a square 0.25. 0.25 means 0.25 by 100, 1 by 4. So into 4 means 1. 5 4s are 20. Yeah, why 1? 2.0 units. First option. B option, length by area. Length is 1 by area. 1 square is 1 only, that is 1 only. And see, I'm not exactly going for just I'm considering only L by R square. I'm considering that will be better. Just I'm considering L by R square. L is 2 by R square is 4, that is 1 by 2 only. And D option is L is 3 by R square is 9, that is 1 by 3 only. So elongation largest is only the first option. Next, in Young's double slit experiment, if the slit separation is twice the wavelength, in Young's double slit experiment, slit separation is twice the wavelength, then the maximum number of interfering maxima is equal to maximum number of maxima that are going to form. You know, we have d sin theta is equal to n lambda. D sin theta equal to n lambda. And theta will be maximum 90 degrees. So d is equal to d by lambda is equal to n. This is upper side number of possibilities. What is d by n, d by lambda? D by lambda is 2. So this is central maxima. Upper side 1, 2, 3, 4 like that. How many comes? Only 2 in number. Bottom side 2 in number and middle central maxima. So totally 5 will come. So n is equal to, I can take 2n plus 1. That means 5 number will come. Oh, 5 check. Yeah. Next, a closed argon pipe of length L and an open argon pipe contains gases of rho 1. This is closed. LC is equal to L, gas is rho 1 and rho 2. Yeah, closed and open argon pipe, maybe open argon pipe also L only. Okay, this is rho 2. Okay, the compressibility of the gases equal, that means bulk moduli are equal. The frequencies of the first overtones are same. First overtone, first OVT, first overtone. This is equal to closed pipe, V by 3V by 4L1. That is equal to, in this first overtone is 2V by 2L. Okay. Yeah. Next, then the length of the open argon pipe is, yes, this is L0. This is different. This is only given. L0 we have to find it up. Yeah. And why did ask the densities? Why did he give the densities? That means the two gases are different. So we need to do velocity in considering densities. So here velocities we need to think in terms of velocity of sound in a gas is gamma p by rho, nothing but square root of bulk modulus by rho. Yes, adiabatic bulk modulus is gamma p. He said compressibilities are same, that means bulk moduli are same. So velocities v1 by v2 is implies v1 by v2 is equal to v1 by v2 is equal to square root of rho 2 by rho 1. This we have to apply here. This is v1, this is v2. So 2 gets cancelled, and here 3 by 4 L v1 by v2. v1 by v2 is root over rho 2 by rho 1, which is equal to 1 by L naught. He is asking L naught. L naught is equal to 4 by 3 L root over reciprocal rho 1 by rho 2. Yes. So 4L by 3 rho 1 by rho 2. Option B. Yes. When 80 newtons, T1 is equal to 80 newtons. When T1 equal to 80 newtons, the length L1 is equal to 101 mm. And T2 is equal to 100 newtons. L2 is equal to 102 mm. And T3 is equal to 160 newtons. Then L3 is equal to how much? If you know T1, T2, L1, L2, then original length L0 can be obtained. L0 is equal to T1 L2 minus T2 L1 by T1 minus T2, right? So T1 minus T2, that is equal to T1 L2 80 into T1 L2 102 minus T2 100 into L1 101 by T1 minus T2 80 minus 80 minus 100. Yeah, this is equal to 80 into 102 6018 minus this is 10100 by minus 20. So numerator also will give you 9, negative will go, positive number only will come. What is that? 101 00 by minus, what is that? 8160. 8160. 8160. 0. This is 4. 10 minus 1 is 9. This 1. 1940. 1940 by 20, that is equal to 97 mm only. All are in mm. This is also mm. Now tension proportional to elongation. So T1 by T3 is equal to E1 by E3. E1 by E3. T1 is T2 will be better, right? Because 100 is there. 100 calculation is better. So ding ding. So I'll take the second one. T2 E2. T2 100 by T3 160 is equal to E2. See, original length is 97. L0 is 97. So this is 102. 102 minus 97 by next L3 minus 97. So L3 can be obtained. This is 0 gets cancelled. So this is 10 by 16 is equal to 102 minus 97 5 by L3 minus 97. So cross multiplication L3 minus 97 is equal to 5 into 16 by 10. 5 2 times, this is 8 only. 8 plus 97 is equal to 105 mm. That means 10.5 centimeter. Correct. 10.5 centimeter. Yeah. A stretched wire of material whose Young's modulus y is equal to 2 into 10 to the power of 11. Activate yourself. Don't get stressed. Poisson's ratio is 0.25. And its lateral strain is equal to 10 to the power of minus 3. Then elastic energy density of the wire is elastic energy density. Energy density means U by V, that is equal to half stress into strain. Half stress into strain. or Young's modulus is given, stress is not there, but strain can be obtained using lateral strain. Longitudinal strain can be obtained using how sigma is equal to lateral strain by longitudinal strain. So implies longitudinal strain is equal to lateral strain by sigma. Lateral strain 10 to the power of minus 3, sigma 1 by 4. I don't want to do in points, I want to do in fractions. 4 into 10 to the power of minus 3, that is lateral strain, longitudinal strain. Now longitudinal strain, stress is equal to, we have y is equal to stress by strain. So stress is equal to y into strain. So half y into strain square, that is equal to half into y value 2 into 10 to the power of 11 into strain square 4 into 10 to the power of minus 3 its square, that is equal to 10 to the power of 11 into 4 4s are 16 into 10 to the power of minus 6. 3 2s are 6 only, yeah. So this is equal to 16 into 10 to the power of 5. So option 16 into 10 power, that only is there. Next, Young's modulus of a perfect rigid body. Young's modulus of a perfect rigid body. Yes, you are right. Young's modulus will give you the what you call the strength of that material. So more Young's modulus, very difficult to deform. More Young's modulus, very difficult to deform. So it's infinity for it. Next, two wires A and B are stretched by the same load. If the area of cross section of wire A is double to that of B, then the stress on B is. Two wires A and B are stretched by the same load. If the area of cross section of A is double to that of area of cross section of B, stretched by same load, so tension in A equal to tension in B only. Then stress on B is stress is equal to tension by area. So suppose stress of B by stress of A is equal to stress equal to force by area. Force is same, so areas inversely proportional. So this is area of B I have to take, B only there, okay, inverse proportional, area of B I have to take. A by B is 2. So stress of B is 2 times of stress of A, twice that of A. Yes. Next, a spring is stretched by applying a load to its free end. Okay, the strain produced in the spring is produced shearing. Many people longitudinal and shear, of course lengthwise as well as shearing. Yeah, many people will feel that only longitudinal. No, longitudinal and shearing. It slides also sideways. That is the reason shearing also have to consider. Next, Young's modulus of a material where A and B are in the ratio Y1 YA by YB. YA by YB is 1:4, while its area of cross section are in the area AA by AB is equal to 1:3. If the same amount of load is applied to both the wires, both the wires, PA equal to TB. Okay, elongation produced in wire A and B will be in the ratio, elongation produced in A be in the ratio of E is equal to FL by AY, So this is same, so no need to write. We can write only E1 by E2 is equal to L lengths not given, moduli of material of two wires where cross sectional areas ratio, same amount of load is applied, the amount of elongation in the A and B are in the ratio. Assume A and B are same. Okay, lengths also same. Then I can write AB by AA and YB by YA, because both are in the denominator, so reverse you have to take. AB by AA, that is 3:1, and YB by YA 4:1. So 3 4s are 12. Yeah. The elastic limit of brass is equal to, that means breaking stress. Breaking stress is equal to 379 megapascal, 10 to the power of 6 pascals. What should be the minimum diameter? Diameter is equal to how much? To support a load of 400 newtons without exceeding elastic limit. So breaking stress is equal to F by area, that is F by pi d square by 4, not pi r square. R can be written as d by 2, so pi d square by 4. Then d square by 4 is equal to F by pi into breaking stress. So d is equal to root over 4f by pi bss. So d is equal to 2 root f 400 by pi breaking stress 379 into 10 to the power of 6. Yeah, 2 into 20 by 3.14 it is. 3.14 into 379, is there any good number? 3.14, 22 by 7 will be better. 22 by 7 into 379, I think 7 will go. 7 5s are 35, 35, 29, 29, 29, only 4 times, huh? Roughly 4 times, okay, 4 times. So 22 into 54, 54 can be, is it existing proper good 10 to the power of 6 also will come as 10 to the power of 3, fine. And then 22 into 54 came. It can be 11 into 2 I can write, and 2 into 27 I can write. So 1 2 will come out. Then 11 into 27, 9 into 3 I can write. So 1 2 will come out, 1 3 will come out. So root over 33 will be left. Root over 33, almost all 5 5 6 6 are 36. 6 I can take, roughly 6 I can take. So 2 3 are 6 6 are 36 I can take. 36 in the denominator, nearest I am doing. 40 by 36. 40 by 36, almost all 1 only, into 10 to the power of minus 3. 1 mm roughly. 0.9 is there, that I can take. 1.16 40 by 36. I think totally he did 36, 1, 36, 40, oh, 1.1. Right. Okay. So no guessings, complete doing. Okay. Next. There are 2 wires of same material and same length, while the diameter of, there are 2 wires of same material, y value same, lengths are same, and diameter of second wire is 2 times that of diameter of the first wire. Diameter of the second wire is 2 times of diameter of the first wire. Then the ratio of extension produced in the wires by applying same load will be, ratio of extension produced in the wire, wires by applying same load, tensions also same. Okay, so E is E1 by E2 is equal to how much? E equal to FL by AY. F same, L same, Y same, huh? Okay, Y same, only diameters. Diameter means I can take up A equal to pi d square by 4, so 1 by d square I can take. So E1 by E2 equal to d2 square by d1 square. So d2 by d1 is 2, so 2 square means 4:1 will be the answer. So should be careful. Squaring you people will forget. Okay, this question's answer. Read the question slowly. Yeah. Mild steel wire 2L, cross section area A. Well, within elastic limit horizontal between the 2 pillars, mass M is suspended from the mild midpoint. Then strain produced in the wire equal, strain is equal to extension C. This is original length. This is original length 2L. And okay, final length will be somewhat greater. Why? Because it is stretched. See, it is stretched. So this length will be definitely greater. So final length that I want to find out. So I can take this as L, this as X, and this will be what is that, some numbering I can give. This is A, this is C I can give, this is B I can give, okay, and this is O I can give, okay. So AC can be AC can be square root of L square plus X square. So it is longer than L. So elongation equal to square root of L square plus X square, square root of L square plus X square minus L 2 times. Why? Because one side only you are doing, the other side, so into 2 times. So it can be L square can be taken common. So L into 1 plus X square by L square whole power 1 by 2. He said small extension X. So minus L into 2. So that is equal to, whenever X is small, you can multiply the power. So L can be taken out. 2L into 1 plus X square by 2L square minus 1. So 1 will go. It will be X square by 2L square into 2L. So 2 will go and LL will go. So it is just X square by L. Elongation is X square by L. Then strain is equal to elongation by original length. Elongation by original length. Elongation is X square by L. Original length is 2L. So it will be X square by 2L square. X square by 2L square. So these are the relations between moduli. Relations between moduli you need to by heart, otherwise you can't derive in the examination in the shortest time. Relation between moduli must be by hearted, then only you can do them fastly. 3262 C. 323262. Yeah, C option. So this is C option. Yes. Next. A force is applied to a steel wire A, rigidly clamped at one end, okay, and as a result the elongation in the wire is 0.2 mm. If same force is applied to another wire B, double the length. This length is double. Here I am taking length L and force F, okay. Here double the length 2L and the diameter is also different, 2.4 times. Here the diameter D. Here the diameter is D dash is equal to 2.4 times of diameter and L dash is equal to 2L. That of wire A. Elongation in the wire E will be. So elongation equal to how much? We have elongation equal to FL by AY. Same type of wire, so this is same, F is same, L is different, A is different, so it is proportional to L by D square by 4. So L by D square is proportional to, you can check it up. So E2 by E1 is equal to L2 by L1 into D1 by D2 squares. You need to substitute. E2 we have to find up. So E1 is 0.2 into L2 by L1. L2 by L1 is 2 into D1 by D2. D1 by D2 is 1 by 2.4 and it's a square. So it is 0.4 into 24/24s. 576, huh? 1 by 576, that means 5.76. So it can be 4 after 0 by 576. So how many times will it go? And the answer will come in mm only. 6.9 roughly, right? 6.9 into 10 to the power of minus 2. So it will be B option. Yes. Next. An aluminum rod and with Young's modulus Y is equal to 7 into 10 to the power of 10 undergoes elastic strain of 0.04%. The strain will be 0.04 by 100 strain on. Percentage change leads to a strain like this, 0.04 by 100. Energy per unit volume stored is So energy per unit volume is equal to half y into strain square, isn't it? So half into y value 7 into 10 to the power of 10 into strain square. Strain square, this can be 4 into 10 to the power of minus 4. It's a square. 16 into 10 to the power of minus 8. Don't square that 4. So this 2 will go 8 times. 856 into 10 to the power of 2. 5600 joule per meter cube energy per unit volume. Then keep on practicing. Many more problems, even practice sheet also there for you. Keep on practicing. Listening won't give you good command. Practicing only gives command on the subject. Practice more. Okay, bye. We'll see another chapter in another session.